In this video, we're going to talk about limits, and we're just going to introduce the definition of a limit and then just describe our general approach to figuring out limits. So right off the bat, let's start with the definition of the limit, and this is an informal definition. It's not really the technical definition, but it's the definition that we're going to use for reasons that I'll talk about a little later. So first off, the definition says, suppose that the domain of a function f contains an open interval that contains the number of a except possibly at a itself. So what this means is that where we've got a function and we want to take the limit at some number a, right? And you kind of think of that a as being on the x-axis. Well, in order to do that, we need for that function to be defined around a, but not really at a itself. And we'll see later on that that's a pretty important idea. Some of the beginning examples that we'll look at, the functions will be defined everywhere, but we'll see later on when the function's not defined at the number a at which you're taking the limit, things start to get a little bit more complicated, but also a little bit more interesting. So we'll use this symbol here, the limit as x approaches a of f of x is equal to L. And what that means is that we can make the values of f of x, right, the y values, the output values of the functions, as close to the number L as we want by taking the values of x, the input values, to be close to, but not necessarily equal to, the number a itself. So in other words, what it means is that if we plug in numbers for x that are really close to a, then the output, or the y values, the f of x values, are going to get closer and closer to the number L there. So as the inputs get closer to a, the outputs get closer to L. So that's the informal definition of limit. And don't worry if you don't understand completely here. It is a complicated definition to get a handle on, and we are going to look at a number of examples to try and illustrate the concept to help to understand what the limit concept really means. So that's the informal definition of the limit, and we're going to use that. Just a couple of notes here, and the way that symbols, or group of symbols, is pronounced, right? It's the limit of f of x as x approaches a equals L is how you would read that statement here. And the other thing is that sometimes there is no value of L that satisfies that definition for various reasons. And whenever that happens, we say that the limit does not exist. So next up, we have the technical definition of the limit, and we won't really be using this in the class. Sometimes when you're learning the limit concept, it seems a little hazy at first, and it is a formal and rigorous definition, but it's also a really complicated definition. So we're not going to use it here in this class, at least at this point. If you're a math major, then you will definitely see this limit definition later on. So there is a rigorous, precise definition, but we're not going to use it. We're just going to use the informal definition. We're going to take three approaches to limits. The first one is numerical, right? The limit, we're going to take some x values that get closer and closer to the number where we're taking the limit, and then we're going to plug those into the function, and then we're going to look and see if we can see a pattern in the output values, or the y values, or f of x values of the function. And that method is really easy to implement and understand, to look at a function numerically like that. But the only downside is that it often leads to inaccurate results. So we're going to do that to begin with, try and get our understanding of what the limit is to a good level. Next, we'll take a look at the graphical point of view of limits, and it's similar to the numerical point of view, except that you're looking at the graph of the function. So there's a picture associated with the problem or function that you're taking a look at, and that helps to visualize again what's going on. but like the numerical approach, there are some graphs that will give you accurate results, and then you don't really want to use those, use this all the time. And so after that, then we'll start building up this analytic approach, right? The analytic approach will take some time and go over the rules of how all that stuff works. And but when you do that method correctly, you will get accurate results. So that's definitely the level that you want to be at when it comes to computing limits like that. And so that's where we're going to be heading to. So next up, we will take a look at a number of examples from the numerical point of view, and then later on the graphical point of view, before we start building up our toolbox to work with limits analytically.